All right, so if we move on, as I indicated, we have two major agenda items. The first one is we're going to review the 2016 challenge, and the second one is I'll provide you with an overview of updates to the 2017 events. The first thing we'll do is we'll take a quick look at the WebText course. So the total scores that one could obtain from the 15 questions that were presented was a total of 1,000. And I think what one can see from these results, so this basically are the scores, and the frequency here tells us how many teams of the final list of about 46 teams that made it to the finals at WebText. These were the score distributions. So we had scores ranging from the low end at about 100 to scores at the top end of about 825. And on average, a lot of teams did pretty decently. What we'll do today is go through some of the strategies that you might want to consider as you continue to approach the challenges going forward. So one of the things we're excited by was that the introduction of the simulator has allowed the process control event to be expanded from one that was in the past mostly focused on a paper and pencil test to one where we can actually provide realistic challenges that operators would typically face in the day-to-day operations of a wastewater treatment plant. We've received a lot of great feedback from all of you. Please continue to reach out to us with any feedback that you have about the questions, about the challenges, about your ability to access the practice sessions, and we'll continue to do the best that we can to be responsive to your inquiries. So as we indicated earlier, the Operations Challenge event, again, the goal there, as the WEF committee presented it and as we've interpreted it and what we strive to do, is not just to provide a simulator platform that allows us to have a realistic scenario in the Operations Challenge event. What we want to do and what we will continue to strive to do is to make sure that those scenarios are as realistic and as challenging as possible. We continue to work on making sure that the simulator is operator friendly and that it continues to be easy to use. And again, we'll continue to solicit your feedback in terms of how you're engaging with the simulator. So the first thing we'll do as we go forward is, for a number of you, the last time you worked with this was during the regional events last year. For those of you who made it to WebText, you certainly worked with the simulator at WebText. But what we'll do very quickly is have a very high-level overview about the simulator. So when you open up the simulator, the key things that you will find is, first of all, the entire simulator itself, if you recall, is a clickable diagram. As you click on different objects, those objects will open up in this middle panel, and you will then be able to make any data input changes, any variable changes that you want. Item number 2 here is an operational summary. So every time you go ahead and you run the simulation, you'll be able to see the impact of any variable changes in this initial operational summary. A number of you might notice that we have another additional operational summary in item number 3. So what item number 2 does is it gives us things like the MLSS, the DO values, the total airflow, sludge production, and now we've introduced clarifier loadings, so both the clarifier loading to the primary and the secondary clarifiers, and here we're talking about the hydraulic loading to the clarifiers. And then in the second operational summary, this is where we summarize things like SRT, the food to mass ratios, and the percentage removals of all the different loading variables. So percent BOD removal, percent total nitrogen removal, percent ammonia removal, and things of that nature. This is also where you will see the energy cost. There's a timer that keeps track of what's going on from a timing perspective. There's a scoreboard where our scores are tabulated and summarized. Obviously, item number 6 is where we see the instructions and the descriptions of each question. And then item number 7, I went over that earlier. This is where we actually see the data input panel. So this is where we're making changes to the different variables that we're trying to impact. And then item number 8, the flyover panel, is where you would see an extended listing of all of the relevant effluent targets. And this is where we'll also be able to see which of the variables we're working on that we've been able to successfully address. Item number 9 here, as you make the variable changes, this is one of the most important parts of the simulator. This is where you actually run the simulator. So there are 4 quick things that we should recall and keep in mind as we go through the discussion. So the first one is we have to click on any unit process that we're interested in on the plant diagram itself. Once we make that click, we can go in and make whatever parameter changes we're interested in making. And then once we've done that, we'll go ahead and we run by clicking on the start button in the bottom right of the simulator, and then we observe the results. So step 1, click on any unit process that we're interested in. Step number 2 is we go ahead and we adjust the parameters of interest. So for example, in this case, we clicked on the aeration tank, and now we have the ability to go in and make changes to the DO controller, or we can utilize an airflow. And then step number 3, this is where we go ahead and we hit the start button and it runs the simulation. And what it means is that every time we hit this run, it takes all the variable changes we've made. So if we change DO from 0 to 2, once we hit this button, it makes that change and it allows the plant, it allows us to incorporate that change into what is going on in the plant, and we then get results. And the final stage obviously is we can then see the results and determine whether those results are the things we're looking for. And if they are, then we're fine, we've met the challenge requirements. If they're not, it means we have to go through that process again in an iterative fashion. So overall, there are about 15 questions that we had for the WebText challenge. Those questions addressed a number of very different issues. So the first question was about a high effluent COD situation. It's a plant where we're not meeting the COD targets and we need to bring that into compliance. There are questions like question number 3 that had to do with both trying to meet a total KLO nitrogen, so a total organic nitrogen, which essentially means in most cases we have to do both nitrification and as we will see in challenge number 3, we also had to think about some denitrification as well. And in the meantime, we have to do that in the context of trying to stay within an energy limit in terms of cost. There are questions that addressed issues of seasonality. So question number 4 had to do with a cold weather type situation. There are questions around total phosphorus removal that would force us and push us into considering things like chemically enhanced phosphorus removal in case the biological process was not sufficient. There are questions around, like question number 9, where we're looking at both the regulatory requirements, which is, your BODs, your total nitrogen, your total phosphorus, but at the same time, this plant needed to also do all of that within the constraints of trying to meet specific energy and specific chemical cost management goals. So again, a variety of different types of challenges. Like challenge number 10 again, for example, this is one in which we're dealing with a high-strength wastewater, presumably a plant that has a pretreatment program where industrial facilities are discharging somewhat higher concentration of wastewaters. Before we go on, very quickly, one of the things we need to talk about as well is what the calculation basis is. So the MLSS that is reported in the simulator is actually the mixed liquor suspended solids from the effluent of the aeration tank. So if you look at the aeration tank, you will see that there are partitions. This aeration tank actually has 4 separate zones. So this is the first pass, the second pass, the third pass, and the fourth pass. So the MLSS value is read from that fourth and final pass in the aeration tank. The SRT is defined as the total mass of solids in the bioreactor divided by the mass of waste-activated sludge. So this is where our WAS is coming from. So the total amount of wasted sludge in pounds per day is the denominator there, and then the total mass of solids in our aeration tank is the numerator. So that's the mass of solids. The DO in the aeration tank is reported at the end of the aeration tank. So if we see a DO level of 2 up here, it would mean that's the DO level in the final zone. And as we go through, I will remind you of what we need to do if we were using, for example, the airflow rate, and we wanted to know what the implication of that airflow rate is for the DO levels in the different zones. Energy cost, anytime we have an energy cost problem, we just need to remember that there are 5 different things that contribute to the energy cost. It's the primary sludge pumping, it's the aeration energy in the aeration tank, it's the internal recycle pumping in the aeration tank, so there's an internal recycle stream. There's a RAS stream, and that's where our RAS pump is, where my cursor is. And then there's a waste-activated sludge pumping cost, which has to do with the WAS control. And anytime we have a chemical cost issue, there are potentially 3 contributors to the chemical cost. It's the dosage of ferric in the preliminary and primary treatment zone, so up there. It's the dosage of ferric in the secondary zone, so in the back end. And then it is the dosage of methanol for enhanced denitrification here in the front end. So methanol dosing, ferric dosing in the front end, and ferric dosing in the back end are the major contributors, the 3 contributors to chemical costs. And then finally, we have the sludge production at the plant, and this is the sludge haulage tank. Is a combination of both the flows from the primary treatment system as well as the waste-activated sludge from the secondary treatment system. Before we go on, one of the things that I would certainly want to point your attention to is that in our different plants, we have different operational parameters and guides that we use both from a design perspective and from an operational perspective. And what I'm just showing here is a table that shows some common operational parameters. They would likely be within the range of many of the things that you do at your plants. They could be different, but typically we're looking at MLSS values that can range, anywhere from maybe 2,000 to 4,000. Food to mass ratios in the 0.2 to 0.5 range in terms of pounds of BOD per pounds of solids per day. SRTs typically within a 2 to 10 day range. Primary clarifier loadings in the 500 to maybe 1,500 gallons per square feet per day range, and secondary clarifier loadings from 200 to 800 gallons per square feet per day range. Why does that become important? There are going to be questions where we may turn off a number of clarifiers, and it's up to you to decide whether you want to bring some clarifiers online or you want to take them offline in order to meet certain targets. There might be questions where just understanding what food to mass ratios might be optimal would be useful in helping to determine whether one needs to bring on board another aeration tank, or whether you might want to bump up the mass, which is the MLSS, in order to push the food to mass ratio down. So it's worth noting these as we go into the questions. So what I'll do right now is I will segue into the simulator itself. And so what I've done is I've turned off the timer so that we don't have to deal with that particular issue. We're going to take as much time as we need to just work ourselves slowly through the presentation. And so these are the 15 questions that you were faced with at WebText. The first question was one in which this plant had to deal with a high effluent CoD. And as soon as you open the question, the simulator has already solved for the first case, and what we can see very clearly is that right now we're not meeting any of the goals. If I click forward, the goals for this particular project is for us to have an effluent COD that's less than 20. Right now our effluent COD is about 306, so we're not doing anything at all in terms of COD removal. And our DO target, we have a DO target. That DO target is between 1 to 3.5, and right now the effluent DO is at about 0. If we look at the summary, we can see that our MLSS is a little bit on the low side. 1 aeration tank is offline. 3 clarifiers are offline. And if we look at the food to mass ratio, we can see very clearly that that food to mass ratio is almost twice what we were suggesting might be your upper bound. So it's about 1.1, which seems to be quite high as well. So perhaps the first thing we'll do in this plant is why don't we just go ahead and turn on aeration? We know we don't have any aeration, or rather we have very small levels of aeration. How do we determine exactly how much aeration we have? We can go to the aeration tank, we can right click on it, and then we can go to outputs. And if we go to aeration, it will show us that the 0 average actually comes from the fact that in each of these different zones we have very, very low levels of aeration. So the first thing we'll do, because it's really easy to do, is we know we have a DO target, so let's just click on the aeration tank. The middle panel opens up the DO. We know we need to keep within a DO target of 1 to 3, so let's just turn on the aeration and let's just go ahead and put DO levels of 2. That's well within the target range. Go ahead and run that simulation. We've now met that target. The key question we have is now the COD levels have come down. We're now close to 20. We're at 24.5, but we're just not quite there yet. What else can we do? Well, one thing we could certainly easily do is we can bring one more clarifier online. And if we bring one more clarifier online, so we can click on the clarifiers, the middle panel opens up the clarifiers, and the next thing we do is we just turn one more clarifier on and go ahead and run the simulation, and that allows us to meet the targets. So we click through next. We submit an answer. We go back to the main menu, and now we're going to go into the second question. So the second question is one in which we're dealing with a plant that has a high effluent BOD and ammonia. Several things to note about this particular plant. So the first iteration that the simulator has gone through is one in which we have very low levels of MLSS. The food to mass ratio is very high. So what that tells us is we certainly want to make sure that we bump up the denominator, increase the mass of solids in the process. The BOD removals are quite low. Ammonia removal, that's not happening at all. We can see that our DO level is non-existent. So a number of things that we have to do in this particular plant. So the first thing we'll do is let's turn on, why don't we just bring the second aeration tank back online. The second way in which we can bring units back online. So one way we can do it is we can click on the unit itself. So in this case, the aeration tank, we can go to aeration tank status. We can click on here to bring it online. So we'll go ahead and do that. We brought it online. We run that simulation. Not much has changed. The next thing we'll do is we know we don't have any aeration. So let's just go ahead, click on the aeration settings. Let's go ahead and just turn this on. Since our target is ammonia removal, let's just make sure we have as much aeration as we need. So let's just have a DO level of 2 across the board. We'll go ahead and run that simulation quickly. Now we're meeting both the BOD and the ammonia targets, but we're still off in terms of the mixed liquor suspended solids. So what can we do? Well, if we are trying to address the MLSS issue. So our target is to be greater than 2,000. Right now we're at 1658. The easiest lever that we have in a plant is to actually use the waste activated sludge rate. So what we're going to do now is we want to increase MLSS, which means we want to reduce how much we're wasting. So let's take that down to about 30,000. So we've done that. The BOD level is just slightly above where we need it to be. And one thing we can potentially do, because it's just a very little amount of BOD shaving that we need, is we can just go ahead and ask ourselves the question, what's going on with my outputs? And if I click on the output and right click so that I see the outfall, even though TSS is not, so here is the TSS 12.3. We can see we have a TSS of 12.3, a 5.1. What we'll quickly do is, why don't we just bring one clarifier online so that we can reduce that TSS level, potentially even get better BOD removal, because part of that BOD value is associated with some of those solids. So now that we've put 2 units online, brought the aeration tank online, we have useful levels, good levels of MLSS. Aeration is sufficient in the system. Now we've met all the targets. We can bank the scores in this case, submit our answer, and then go back to the main menu. The third case, so I'll just quickly check in through the questions. There was a quick question on whether there's a PowerPoint. The answer is yes. We will not be making the PowerPoint available just yet. But yes, there's a PowerPoint, and at a future date we will make the PowerPoint available, and we'll be sending that across to everyone. Okay. So in this particular question, we have a high TKN target. So we have a situation where we have a high TKN, and the effluent TKN is currently over 5 milligrams per liter. Right now you can see it's about 10.9. The DO, the target is between 1 to 2.5. You can see here that the DO is actually pretty high at 7.7. And then the MLSS is required to be at about 2,000. Our MLSS is actually much lower than that right now at about 1,300. And we have to meet all of the treatment goals in the plant while still maintaining energy at a reasonable value. So the first thing we'll do is we can see very clearly in this case that so 2 clarifiers are off, 1 aeration tank. We have only 1 aeration tank that's online. Our foot to mass ratio is quite high. We need to meet a TKN limit. So one thing we can certainly do is, if we clicked on the aeration, we can see that the aeration is quite high right now. Right now we're using about close to 6,000 cubic feet per minute. We know that that can potentially be optimized. So what we'll do is we will go ahead and we will perhaps try to modify that. So from 6,000, we'll bring it down to about 4,000. That helps with energy, but that's pretty much the only thing that we were able to use that aeration change to achieve. The other thing we'll do as we look at the values, so obviously the DO level is still much higher than it should be. The mixed liquor suspended solids level is still much lower than the target. One of the things that's clear is that the foot to mass ratio is also still quite high. So we have 2 options. So one is, do we bring another aeration tank online? Well, that will have the impact right now, if we did that, of reducing the MLSS even further. So what we'll do is we'll try to use wires control to bump up the MLSS value. So what do? In order to increase the MLSS values, we have to decrease the WAS. Right now, the WAS rate is about 150,000. Why don't I will shave that back to about 75,000 and see where that gets us. So that helped us a little bit. It's not solved the issue for us. So let's go ahead and let us take this to 50,000. So reducing the WAS rate from its initial value of 150,000 to 50,000 has now allowed us to meet the MLSS requirement. So wasting less sludge allows us to increase MLSS. We've reduced energy because we pulled back on the aeration. We've been able to meet the TKN requirement. But one of the things that what we've not yet met is the DO target. So we need to go back into the aeration tank. The total airflow right now is 4,000. In order to meet this DO target, we need to reduce this. So let's just shave it back a little. It's 4,000 right now. Let's make it 3,800 and see if that helps us meet our goals. It's still down, but it's not quite where we need it to be. Let's make it 3,600. See where it gets us. We're still not quite where we need it to be, so maybe we can even go down further a lot more, and there we go. So taking the aeration levels down allows us to meet the DO target. We're able to meet the mixed liquor target. We're able to stay within the total energy usage requirements in the plant. And then from a TKN perspective, we're able to both achieve ammonia reduction as well as overall TKN reduction. So we've resolved that particular challenge. We can cycle through, submit that answer, and go back to the main menu. I see a question, so let me just quickly take a look at the question we have. Will this presentation be archived? The answer is yes, it will certainly be archived, and we'll make sure we have it available to you. The reason why we're not making it available yet is that there is an update that we'll talk to you about of the new challenge questions that are coming through. But there are a number of, until that is released, and that release is going to be in a couple of weeks. Certainly by next week you should have the trial, the test version of the challenges for 2017 out. Until that's done and the questions that go with that are set, we just want to make sure that this particular challenge that focuses on what was done last year and that is in some ways related to some of the things that folks are doing right now is not out there floating around. So everybody will have this in a couple of weeks, so and we'll make sure you're all aware of that once it's released. So the next thing we'll deal with is question number 4. And in question number 4, the challenge we have here is that the plant has a high effluent total nitrogen. So the total nitrogen goal is to be less than 6. Right now we're at about 23.9, so almost 24. But the additional issue we're dealing with is that this is a cold weather situation. So we're dealing with seasonality. If we click on the influent, you see that the flow is 4 mgd. The temperature is about 53 Fahrenheit, so this is a winter type situation. The COD is reasonably high, and we need to be able to ensure that we meet the effluent requirements while thinking about these challenges. So the first thing that we'll do is if we look at the SRT, it's reasonable. The food to mass ratio is a little bit on the high side. MLSS is low. So the first thing we'll do is let's just turn all the systems online. So as I said, there are 2 ways to bring systems online. For the aeration tank, you can just right click. You'll see that in service, there's nothing ticked. If I click on that, it brings it into service. If I right click now, you see that if a unit is in service, it's going to have a tick. So that's in service. If I did that for the second aeration tank, you see that they're both in service now. The other way to bring systems online, I'll do this with the clarifiers, is click on the units. The middle panel opens up the units. I can go ahead and just click online, bring them all online, go ahead and run the simulation, and now all the systems are online. That's not helped us much. One issue that we need to deal with, obviously, is if we look at the operational summary, the DO levels are 0. So what's going on? We're not using a DO controller. We're using a total airflow. So to just perhaps make things a little easy for us, let's switch on the DO controller. We want to make sure we have enough aeration. But we also, so we could go ahead and just put a DO level of 2 across the board. The challenge, though, is we know we need to meet a total nitrogen limit, which means that at least one or more of our aerobic zones have to have low DO levels. We need to make them anoxic. So let's make the first 2 zones anoxic. Let's make the last 2 have a DO level of 2. Let's run that again and see where it gets us. So that was sufficient. We have enough aeration to make sure that we're nitrifying fully, and you can see that the ammonia levels are now at about 0.4. But by creating these anoxic zones in the front end, we're able to also ensure that we are denitrifying as well. And that allows us to meet the total nitrogen limit in the plant right now. So we'll take those results, we'll go ahead and we'll bank them, and then we'll go back to the simulation and we'll go to question number 5. So question number 5 is one in which we are dealing with a high effluent total phosphorus level. The influent loading is similar to what we had in the previous one. So this is also still a cold temperature situation. It's 4 mgd on the influent. The temperature is about 53 Fahrenheit. That's what we're dealing with. So the first thing we'll do is the DO level is a little low. The MLSS is about 2900, which is not too bad. But the first thing we're going to do is let's just turn all these units back on. So I'll turn on the aeration tank. We'll go to the clarifiers and turn all those units back on, and then run the simulation. So that's sufficient to allow us meet this TSS target. Remember that part of the goal we have, so we have 3 goals. We need to meet a TSS target. We need to meet an effluent total phosphorus target. And right now we're way off on that. And then we also need to make sure that the chemical dosage cost is where it needs to be. As we look across the plant, we'll see that most of the things we're doing are, the MLSS seems to be reasonable. We're meeting the TSS limits. We don't quite have a BOD target. We are not meeting the total phosphorus target. So if we just narrow down, so the other thing we can do is, we can just go ahead, turn on the aeration system, run the simulation, make sure that and by turning the aeration system on, you'll notice that the total phosphorus level dropped a little bit. The BOD levels dropped as well. So the reason why the total phosphorus levels dropped somewhat is because the bugs, we have more bugs in the system now. They're doing BOD removal, and the bacterial cells obviously need some nutrients. So we've tried to use the biomass to remove as much phosphorus as we potentially can. And now we seem to be at the limit of what the biological system can help us do. So what we're going to do is we're now going to try to use a chemical step to address the phosphorus issue. So there are 2 places where we can dose ferric to help us with phosphorus removal. We can do that in the front end ahead of the primary clarification system. And then we can also do that at the back end ahead of the secondary clarifiers. A lot of plants will do one or both. So what we'll do is we'll do a little bit of both. Our current TP level is at 5.91, so let's add about 100 pounds in the front end. So from 5.91, let's see where that gets us. So we run the simulation. That gets us down by about to about 4.79. Let's go ahead and dose a little bit, about 100 as well, to the back end. Run that simulation. That gets us down to about 3.18. Let's again go to the front end. It looks like every time we add about 100, we're removing somewhere in the 1 to 1.5 milligram per liter phosphorus range. So let's bump this up to 2 in the front end. Now we're at about 1.7, and we would expect that if we bump this up by another 100, that should hopefully get us where we need to be. So that gets us, so doing that gets us to where we are looking to be. The challenge, though, is, we're certainly not meeting our chemical dosage cost. And you'll notice that when we added that last bit of phosphorus, we also went out of whack in terms of TSS. One reason why that might have happened is because as we increased phosphoric dosage, the MLSS levels also went up. We're forming more ferric precipitate. So the phosphorus is precipitating as a solid. It's part of the MLSS. We're sending more solids to the clarifier. So the first thing we'll do is, before we take care of this TSS issue, let's deal with this chemical dosage issue, because right now it's the easiest thing we can deal with. And why is that the case? We know that there are only three things that contribute to chemical cost. It is ferric dosage in both the front end and the back end, and then it's methanol dosing. Right now, we have 500 pounds of methanol. We really don't need methanol in this question. There's nothing to do with total nitrogen. That's not a target. We can make that zero, run the simulation, and now that helps us meet all of our targets. By removing that methanol, we're removing some COD. That COD was being turned into MLSS. It was consuming some oxygen. It was increasing the solids concentration, increasing solids load into the back end, and by just removing that, it addressed both the cost issue as well as helped us shave off some of the solids in the system, which brought the TSS in the effluent down. So again, this is an example of these interrelated things that we have to deal with in the context of wastewater treatment. So let's bank that answer and then go back to the main menu. So right now we'll go to question number 6. Before I do that, let me quickly take a quick look at the questions. So the question was, are points deducted each time you press play? The answer is no, points are not deducted. Each time we press play, the system simulates, and then the only points that we get is whatever points are scored here. So you can make whatever changes you need to make. You can add variables, remove variables. All that's important as far as the challenge is concerned is for you to do what you need to do within the time limit that is allotted. How you do it, what changes you make, and how often you do that, there's no penalization for that at all. All right. So please keep the questions coming. I will be addressing them periodically as we go on. The next challenge is one in which we have a plant where we're dealing with a high BOD situation. So the BOD is 114. The target is to be less than 10. And ammonia, we want it to be at about less than 1. Right now it's 27.4. In terms of the influent, the temperature is still low. The influent flow is about 4. So the first thing we'll do is we need all the help we can get. Let's bring all of our systems online, put the clarifiers back in service and the aeration tanks. Go ahead and run the simulation. And now that we've brought so everything is back online, our DO level seems to be on the low side. So maybe one thing we can quickly do right away is let's go in and just address this DO situation. We have an effluent ammonia target. We don't have an effluent total nitrogen target, so we're not so concerned about denitrification. We just want to make sure we have enough aeration. So let's just put a DO target of 2 all across the board. We'll go ahead and we'll run the simulation. So that allows us to meet the ammonia target. We have all the oxygen we need. We're nitrifying, but we're still not meeting the BOD target. As we look across the process, the DO seems fine. The MLSS is, within that 2,000 to 4,000 range. That cannot be the main cause of whatever challenges we're facing. So the effluent TSS is at about 11. So yes, even though the MLSS is high, that's really not why we're having these really high BOD levels. So it looks like we're not able to achieve BOD removal, which is one of the most basic things that we should be able to achieve. It's a little more difficult maybe to nitrify because that depends on SRT and making sure that's in order. The food to mass ratio is reasonable. So as I look at this summary, the immediate thing that jumps out at me is that it appears as if the total phosphorus, we're removing a significant amount of phosphorus, yet we're not doing much BOD removal. And as we look at the soluble phosphorus level, we can see here that we really don't have any soluble phosphorus in the effluent. We've removed it all. And which might mean that we're actually limited in this plant in terms of phosphorus availability. So what that tells me is we might be dosing a significant amount of ferric. And the answer is yes. So there's a lot of ferric dosage, 1,200 pounds in the front end. In the back end, yes, we're also dosing quite a high amount of ferric in the back end. So what I'll do straight away is, why don't we take this down, to about 200 in the front end. And there we go. So that was sufficient, just removing all of that ferric, or most of it in the front end. In fact, we didn't even need to touch what was in the back end. It still looks like we're dosing way too much ferric. But we've met the goals. There's no additional goal that we have. If there was a chemical cost goal, we can go ahead and begin to shave even more ferric from the back end. But we've met the challenge requirements in this case. We can just go ahead and bank those answers and then go back to the main menu. So the next question, question number 7, is one where we're dealing with a high total nitrogen. In this case, the total nitrogen, the target should be 8 or less than 8. Right now, it's about 17.5. We also have a chemical dosage cost target. So we want to make sure we can meet the total nitrogen target while at the same time keeping within a certain cost in terms of the chemical dosage costs. So what we'll do is we will, as we look through, we have a number of units offline, so let's bring those units back in service. Click on the clarifiers. Let's use the alternative way of bringing those clarifiers in service. So we've put all those units back in service. We are still not where we need to be. If we look quickly, we have an SRT that is at 3.2 days. MLSS is still quite low. So one of the things we probably want to do is we certainly want to bump up this MLSS value, which should also help us bump up the SRT value. Right now we're wasting about 100,000. Why don't we just take that down to about half so that we can almost about double both the MLSS and the SRT. We'll go ahead and we'll run that simulation. We're not quite where, we're certainly not even close to where we need to be. So as we look at what we are doing here, we need, the target here is total nitrogen. If we look at the flow, the total air flow here is about 58, close to 60 cubic feet per second. We do not have, so we've not optimized what is going on here in terms of aeration. So what we'll do is, why don't we just switch to, so I'll switch over to aeration flow. This is about 60. If I multiply this by, if I make this in cubic feet per minute, this is close to maybe somewhere between 3 to 4,000 cubic feet per minute. That would get me to the DO targets I have now. I'll make that a little lower than that, just so that I'm within a range where I can get some reasonable anoxic sections in the front end. And then from a chemical dosage perspective, one of the issues that I have is right now my dosage costs are quite high, about almost 50% higher than they need to be. So let's see where the dosage costs are coming from. They're coming from ferric. There's nothing there. We'll go to the front-end ferric. There's nothing there. There's only one option left, which is methanol. And this is telling me that this is the only option that I have to save on chemical cost. I know that this costs, right now, my target is about 2/3 of what this is. So I need to take this down to at least about 300 if I am going to meet my target. The issue that I have is I've now run into a situation where now my total nitrogen level is higher. So what I'll do is I probably need to come here. My DO is high. So let me come here and shave back so that I can create some anoxic zones in the system and use that potentially to provide some natural means for denitrification. By just having those anoxic zones, I will knock down the amount of aeration that I'm providing and run that simulation again. And now so you can see that the effluent DO is 2.2, but if I right click on the aeration tank and I go to outputs and I go to aeration, you will see that aeration value, even though we're leaving in zone 4 with about 2.2 milligrams per liter, both zones 1 and zones 2 are actually very nicely anoxic. Those DO levels are between 0 and 0.5. Those are the types of DO levels that you're looking at in order to create a nice anoxic zone. So I'm nicely anoxic in those front-end zones, and that allowed me, even though I pulled back on methanol, to actually create an environment where I could use some of the soluble COD available in the front end of the plant to help me with denitrification. So we'll bank those answers and we'll cycle through very quickly to question number 8. This is a question where we're dealing with a low SRT and MLSS situation. So in terms of targets, our target is to have a minimum SRT, a minimum MLSS of about 2,500, an SRT within about 6 to 12 days, an effluent TSS of about 10 and less. Right now, our MLSS is about 2,000. Our SRT is about 5.4 days. We will see that in terms of the influent, it's 5 mgd. The temperature is about 72 Fahrenheit. But what we'll do is, let's just bring all the systems back in service so that we're not limited in terms of that. Let's run. And just bringing all the systems back in service actually helped us to meet quite a few of our goals. It helped us to meet the TSS goal. And right now we are just on the verge of meeting the SRT goal. That could still change, but at least now all the systems are back in service. The next thing we'll do is we can see that our DO level is low. So maybe one thing we will right away do is let's turn on aeration. We're still dealing with that TSS issue, but also, so the TSS is high, but we can also see that our MLSS seems to be on the slightly higher side. And we can see that, we can actually pull back a little bit on the MLSS and still stay within range on the SRT. So we'll go to WEF control and we will increase. So right now we're wasting about 22,000. Let's bump that up to maybe about 40,000 so that we can bring that MLSS down close to about 2,000. So now the MLSS is at the target. We wanted it to be greater than about 2,500. It's now about 2,800. The SRT is well within range, and then our TSS is also just at the point where we want it to be. We can go ahead and bank that. And then we'll go back to the main menu and we'll go to question number 9. So this was the highest scoring question. for obvious reasons. We're dealing with both energy and chemical cost management in this particular question. And if we look at the plant itself, our target is, we have a TSS target, we have a TKN target, we have a TP target, and we also have an energy cost target. So the first thing we'll do, if we look at the operational summaries, our DO level is quite high. That immediately tells us we can actually optimize aeration. The MLSS seems to be, somewhat reasonable. It's below that kind of 2,000 range, but it's still somewhat reasonable. Our SRT is quite low. So if we intend to do anything with TKN removal, we need to take a hard look at this SRT, because we need a reasonable SRT in order for us to do nitrification. And right now we're not doing any nitrification. The ammonia level is about 23. TSS levels are quite high. So let's just go ahead and quickly put all the systems back online. So we'll put all the clarifiers online, put the aeration tank online, go ahead and run the simulation. Bringing everything online helped us with the nitrogen and the phosphorus targets. Now we have to deal with the energy and the TSS issue. So one of the things we'll do is let's go to the DO controller. And perhaps what we'll do is let's turn on the DO controller. Let's leave the default variables in, and let's just run and see what impact that has. So that helped us with the energy cost. We're still fine in terms of TKN. The total phosphorus is still reasonable and decent. Both aeration tanks are online. All the clarifiers are online. The issue we're dealing with is that the TSS level is somewhat on the high side. The chemical dosage cost is also quite high. So one of the things we're going to take a look at is whether there's anything we can do in terms of chemical dosage. So the options we have are the ferric. There's nothing in methanol, so the only thing we can do from a chemical dosage cost is actually on the 2 ferric dosage sites. So let's go ahead and right now the cost here, we need to be at 65,000. This is almost 150,000. So that's about, certainly more than twice where we need to be. So let's go ahead and dial back on both chemical dosage points. If we're to get anywhere near the target, we need to be dosing only about 200 and not 500. And then let's see what the impact of that is on the plant operations. And then we can begin adjusting from there. So we've met quite a few of our requirements. The only requirement we've not met now is the TSS requirement. It's still a little bit on the high side. So what we'll do now is we'll just essentially use perhaps waste activated sludge control to perhaps reduce. So if we look at the secondary clarifier loading, this seems decent. This is the hydraulic loading, so the amount of flow going. It doesn't tell us about the amount of solids going to the clarifier. So the solids are determined by the MLSS. What we want to do is maybe dial back a little bit on the MLSS by increasing the WAS flow. So we'll take this from 50,000 to perhaps 70,000, run that simulation, and now that allows us to dial back from an MLSS that was in the about 2,800, 2,900 range. We've brought it back to about 2,200 now. We're meeting all the requirements. We've reduced a little bit of the solids load into the clarifier, and that's helped us meet overall the goals that we have in this particular challenge. We go ahead, we submit that, go back to the main menu. So that was question number 9. And now we'll go to question number 10. So I'll just quickly pick up the pace here as we near the 1 hour mark. So the challenge here is it's a high strength wastewater. And if we click on the influent, we'll see that it's 5 mgd. Temperature is about 72 Fahrenheit, but the COD is quite high. So this might be something that a plant would experience if, for example, as I indicated earlier, a facility is possibly, maybe has a pretreatment program, and there might be some industrial influence that are coming into the plant. So the first thing that we will do is all the systems are already online. The DO seems fine, airflows are specified, the SRT seems fine, the F2M ratio is 0.61, slightly on the high end, but you know it's well within range. So the first thing we'll do is, you know, let's go ahead, let's just click forward to see what the targets are. So the target here is we have an airflow target. We've been told the airflow is going to be at or just less than 3,500. So the easiest thing we can do is just go into the aeration tank. My DO levels aren't really helping me because I have to be, you know, changing DO levels to try to determine what the airflow is. But since airflow is specified, let's just turn off the DO controller and just make this airflow rate just slightly less than the target. So I'll put it at 34.99. The target is 3,500. So I've met that. The issue though is my effluent CoD is supposed to be just less than 130. Right now I'm still at 221. So I need to find a way to dial back on that CoD. But as I look here, I see that my soluble phosphorus levels appear to be very, very low. And I'm actually starting to suspect that maybe I am dosing a little too much ferric. So let's dial back on that. I will take that to 200 in the back end. Take that to 200 as well in the front end from 500. Run that simulation. We're low. We've gone from being in the 200s to now being at 142. So that helped us somewhat. But there are other levers we might have. You know, one thing we could do is, you know, maybe go ahead and maybe dial back a little bit more in terms of ferric dosage, or we can use sludge wastage as a strategy. And, you know, both options are available to us. One thing we can do is, you know, just maybe waste a little more sludge, but in this case, we might as well, we can just, again, go ahead and we could take off all of the ferric. We know it helped us. Let's see how far that gets us. Well, taking off all the ferric allowed us to meet the effluent goals in this case. We could have certainly also met those goals by perhaps adjusting the WAS rate to reduce the MLSS a little bit so that the solids load into the clarifiers could be reduced somewhat as well. So we'll bank that question. That's been answered. We'll go to question 11. So I'll just pick up the pace here. So here the target is SRT control. We see that the MLSS is quite low. We have no DO, no reasonable levels of DO in the system. 3 clarifiers are offline. So the first thing we'll do, this is about SRT control. This is about solids. I want to make sure I have all the clarification capacity that's available. So I turn on my clarifiers, run, and the next thing that I'll do is just go ahead and make sure we have aeration. Turn on the DO controller, leave it at the defaults, go ahead and run that and see where it gets us. So we're able to meet the BOD target by doing that. We still have a number of targets. There's an SRT target, there's an effluent phosphorus target. In order to, if we look at the soluble phosphorus, it's at 6.6 right now. We need it to be at 0.1. So let's go ahead and dose ferric to both the front end and the back end. Right now we're at about 25. Let's bump that up to 200 first. Let's run that. So now we're at 6.6. Let's see where that gets us. It takes us from 6.6 to about 4. So we have quite a ways to go. Let's bump up what we have in the back end as well. Let's see how far that gets us. We're moving closer. We still have some ways to go. So we're at 1. We need to be at less than 0.1. So let's bump this up to 4. We'll run that again. So we've met that target, and now we just have to deal with the SRT target. The easiest thing we can do, we're at 10.5. We want to, in this case, waste. We want to waste more sludge so that the SRT comes down. So from 45,000, let's just make that 65,000. And that allows us to go to an SRT range that is well within where we want the plant to be. So we bank that, submit that answer, go to the main menu, and now we can go to question number 12. This is an energy management question, and in this particular challenge we have 3 goals. We want a BOD that's less than 10, we want a TKN that's about 3, we want total energy to be no more than 190. This is also one of those situations, if we click on the influent, where the temperature is low. So we have to do all this in the context of a low temperature situation. So the first thing I certainly want to do here is bring all my units online. We need all the help we can get. So we bring all the units online. We run the simulation. So that's sorted in terms of making sure all the units are online. But we have an energy target, and most of that energy is likely to be coming from the aeration. So right now, if we click on the aeration, this is about 6,000. We can dial back on that a little bit, make that about 4,500. That reduces the energy cost somewhat. We're still not where we need to be. There's still some work to do. So where is our energy cost coming from? If you recall the table we discussed at the beginning, energy comes from the WEF control. So maybe there's something we can do with WEF. Energy comes from the RAS pumping, and energy comes from the aeration tanks. We've adjusted the aeration. We're pretty low with aeration. It doesn't seem like there's much more we can potentially be doing here. But if we look at the RAS, this is about 10. If we click on the influent, that's at 6. So it looks like we might be moving more RAS than is required. Your typical RAS ratios would be anywhere from about 0.5 to maybe 1 from a RAS to influent ratio. So there's some room to pull this back. So let's pull it back somewhat. So that helped with energy. So now we have to look for some of the other ways in which we can impact what's going on. The MLSS clearly, when we made that move, is pretty high. It's way higher than we want it to be. So in this case, what we're going to do is we're going to use the WEF control to try to bring that MLSS down. Right now we're at 37,500. Let's bump that up. It's about 40,000. Let's bump that up to about 80-something thousand to bring that to within the 2,000 range. We're moving closer. So TKN is now just 3.2. The BOD is well within range. So we can still do a little bit more here in terms of wastage. So let's take the 8 to 10. Let's see whether we keep moving in a positive direction. And yes, that was sufficient. So by increasing the RAS rate, the WAS rate rather, bringing down the MLSS, shaving the aeration to meet the TKN target as well as the total energy cost, we're able to meet the challenge requirements there. So let's bank that answer quickly. Go back to the menu. That was question number 12 and question number 13. Here, the goal is total nitrogen removal. First thing we'll do, let's put everything back in service. Run the simulation. Our goal is we have a total chemical cost goal, and we need total nitrogen to be less than 10. Right now, total nitrogen is quite high. You can see that we're doing a good job of ammonia removal. So that's not our problem. Our problem right now is denitrification. There's a lot of nitrates in the system. So what we'll do is we'll go to aeration. We can see that we don't have an anoxic zone. So the first thing we want to do is let's create an anoxic zone and see how that impacts. Well, we have an anoxic zone. We didn't see much of an impact. The chemical dosage cost is just slightly higher. Chemical dosage tends to come from both our ferric, there's no ferric here, in the back end. There's no ferric in the front end. And if we look at methanol, well, we have methanol here. But so let's see if shaving, we just need this chemical dosage cost to be less than 700. We need methanol because we're trying to do denitrification. So let's see where this gets us. We've met that methanol dosage. We cannot go higher in terms of methanol because that's the only chemical cost. So what we're going to do now is we have to use the biological process to help us with denitrification. So if we click on the aeration tank and we click on outputs, we can look at something called profiles. And what profiles does is we can see from the profiles that in the first zone, we have a lot of soluble CoD. It means we have a lot of the readily biodegradable carbon that the bugs need for denitrification. Well, why are we not seeing good denitrification? If we scroll down, we will see that the nitrates, so if you look in zone 1, we have no nitrates at all. We have completely denitrified in zone 1. But in zone 4, we actually do not, we have a lot of nitrates in zones 2, 3, and 4. So what we want to do is to find a way of moving these high levels of nitrates from zone 4, where we have a lot of nitrates, but where we have, if you go back up, no soluble CoD, it's only about 4 here, to zone 1, where we have a lot of CoD that can help us with denitrification, and where we have no nitrates. So how do we do that? The way we do it is we use something called the internal recycle. So what this does, it helps us move material from zone 4 back into zone 1. And typical values is somewhere between about 1 to 4 times your influent. So right now our influent is 8, 4 times our influent is 32. Let's just go ahead and make this about 25 in terms of that internal recycle flow where we're moving nitrates from the back end to the front end. And just doing that allows us to leverage the biological process to allow us to do denitrification. So a lot of you that have, internal recycle streams in your aeration systems, that's actually the principle of what's really going on. You're trying to move nitrates from that back end with a lot of nitrates to the front end where you have a lot of readily biodegradable CoD and already a low nitrate environment. Question 14, we're maintaining clarifiers in this case. And what we're trying to do is to make sure that we meet a BOD target and an MLSS target, given the constraint that we have, we don't have all our clarifiers available. And a lot of plants would go through that, for example, during maintenance. So if I click on the clarifiers, you will see very clearly that 2 are grayed out. I can't do anything with them. I can bring at least the one that I have available online, bring it online, run the simulation and see what happens. I am still not meeting my BOD target. I am not meeting my mixed liquor target. The next option that I see that I have no dissolved oxygen. So let's go ahead and just provide oxygenation to the process. Let's run that simulation. So making oxygen available allows us to meet the BOD target, and all I need to do now is meet my mixed liquor target. I want to increase mixed liquor, so it will probably not serve me too well to bring on another aeration tank because that would make the MLSS lower. So I'll maintain the single aeration tank, and what I'll do is I'll just use WAS control to help me reduce. So right now I'm at 15,000 gallons per day. I need to bump up my MLSS by at least a factor of about 2. So what I'll do is, just take this down to about 7,000 from about 15,000, just a little over half in terms of reduction. I am close, but not quite close enough. Now at 2,500, I need to be at 3,000. Let me go ahead and just shave this again, take that to 5,000, see where that gets us. I am close, not yet close enough. Let me take that to 4,000. And this should hopefully do it. So yes, we're now where we need to be, and we can bank that answer and go back to the main menu. And now we're at the final question where we have cold weather situation We have no ability to control the DO. So we can't use DO control, but we want to control SRT, and we want our DO to be within a certain target range. So what we'll do is, if we, the first thing we'll do is, if you clicked on the aeration tank, right now we're at about 1,000, and the DO level is 0. If we right-click and go to outputs and we look at aeration, we can see that the DO is really, really quite low. So let's bump that up, take it to about 3,000, see where it gets us. So that puts us kind of within a range where, a decent range where we want to be. The challenge we have, though, is we're still off in terms of SRT. So one thing we can obviously do in this particular case is the easiest lever we have available to us is the WEF control. By reducing the wastage rate, we can increase the SRT. Right now, our SRT is about half of where it needs to be. So what I'll do is just halve our WEF flow rate so that we put ourselves within the range of doubling the SRT. And so from 80,000, let's go to 40,000. And what happened? Well, our SRT is now slightly below 10, but our DO level also went down. So what happened when we reduced the WEF flow rate is our MLSS obviously went up, and now we're consuming more oxygen. So let's go back to the aeration tank. Let's put in a little more oxygen. Let's run that simulation. And yeah, so running that simulation, putting in a bit of oxygen, allows us to meet the DO target, allows us to meet the SRT target as well. We go ahead, we bank that. So those are the 15 questions. I will just very quickly go back to the presentation. So what you'll find going forward is we will post this presentation, and what we have in the presentation are the different challenges as well as some potential solutions. So for example, in this case, for challenge number 1, there are a variety of solutions. You don't have one answer. There are no two plants where you have just one answer to a question. So what we need to do is, so in this case, we're showing you 3 different alternatives that would have gotten us to meet all of the challenge requirements. And we do this for all of the questions. So for every single question, so challenge number 2, these are 2 alternative options that also get you to the answer. Challenge number 3, these are 2 different options. In this case, we're using DO control. In this case, we're using aeration. In this case, we're bringing only 2 clarifiers online. In this case, we're bringing all the clarifiers online. In this case, we're wasting 40,000 gallons per day. In this case, we're wasting 50. So this is reflective of reality, that there are different strategies that can get us results. All of this is going to be available to you in a couple of weeks, and we'll let everybody know when that's available. What I'll do now is I will go and discuss what's coming up soon and talk about how to access the simulator. There was a question about that. So for the 2017 challenge, there are 2, maybe 3 major things that are coming. So the first one is it's still a full plant, and by full plant we mean it goes from influent to primary preliminary treatment to secondary treatment. And now what we're adding this year is there's going to be solids handling, so there's a digester, so there will be questions around digester operations. There's also disinfection, and right now the only disinfection approach that we're using is chlorination. So there will be some challenges around chlorination. There will be some challenge questions around digester operations, in addition to the usual challenge questions about the plant operations in general. We have expanded the operational summary. So if you recall, last year we used to have just 1 high-level summary. Now we've broken it out into 2. We've included things like the F2M ratio, the percent removals, Energy costs had always been there. We've just separated those and moved them apart. There's SRT, and then there's the loading as well, so that you can very quickly begin to determine whether your clarifiers are at a point where they are hydraulically limited or not. And then we've had a number of people that have asked questions about the simulator. So the first thing is that the simulator platform itself that you need to test for your tests and for your for WebText are completely free. They're available online. I will show you right now the link. You can always send us an email or you can copy down the link when I send that link, when I show you what that link is. But it's available. It's completely free. Everybody that's taking the challenge, your teammates, you know, folks at your plant, you can just reach out to us, send us an email, let us know it's about the challenge, and you can access this completely for free. There are, however, a number of you that have been asking us questions about whether customized versions of the simulator could be available for your plants. The answer is yes. That's part of what we do. So for example, this is a wastewater plant. This is the bird's eye view of the plant. This is that plant replicated in SimiWorks. So you can see the clarifiers, you know, the 6 of them, front end, the back end, the front end clarifiers, the back end. So this is that plant. So it provides you with all of the things that the simulator allows you to do. It's just customized to your plants. So for those of you that have those questions, you know, just reach out to us, send me an email, send our support line an email, and we'll be able to talk to you and your plant management. It can be done both for the bird's eye view of the plant, and we've also had folks that have been interested in just replicating the SCADA system. It's the exact same thing. So in the same way that you run your SCADA, you click on it, you make your changes, we're also able to provide this simulator in that form as well. And these are just different types of the simulator that have been done for different plants across the country. Some of them in SCADA view, some of them in bird's eye view form, all of them customized to whatever that plant is interested in. And I can follow up with, again, any of you that have questions around that. All right, support. How do you get support? So we have a YouTube video channel where this particular presentation, this discussion we just had, will be posted, and that should occur within the next couple weeks. There's a pretty cool video that was done by WebText, by WEF, that covers the 2016 challenge event. It's just 3 minutes. If you haven't seen it, it's you know, pretty useful. I think you'll really enjoy watching it. This is the link. If you have questions about how to access that link, you know, just let me know. I'll be more than happy to make that link available to you. And then for those of you who want the trial versions to practice for your regional competitions, or to just, you know, have a go at the simulator if you haven't worked on it before, you can always go to this website, so www.hydromantis.com/optool/requestform.html. Click on it. It will take you to this page. You can download the simulator. We encourage you to take the survey. That helps us know how the simulator is being used and things like that. But you can go ahead and just download this. Or you can just shoot us an email. You can send me an email for b@hydromantis.com or support@hydromantis.com, and we'll send you the link to this download. And once you go on this page, you download the form, you fill in the questionnaire that comes with it, that automatically generates a request, and what you will get from us is an email with a key code that allows you to use the simulator. So that is the end of our presentation for today.